For the global positioning system, they try to get the satellites to go around the Earth either once every 24 hours, but I actually think it's every 12 hours is what it is, and then they can synchronize it that way. So in other words, you have to know how to calculate gravitational forces to figure out how to get you around the Earth in the right time. Now how about this? If we were to change its orbit so that it is now at an altitude of 50 kilometers, would you have to speed up the satellite or slow it down? So we want to go further away from the Earth. So let's try to think about it. What's actually holding the satellite in orbit? What holds us in orbit? Yeah, the pull of the Earth's gravitational field. And is gravity stronger or weaker as you get further away? Up here, it's a lot what? It's weaker. In fact, if you're twice as far, it's 4 times weaker. This is actually more than that. It's 50 compared to 20. So it's like 2.5 times weaker, right? Or 2.5 times further, so 2.5 squared, whatever that is. So it's at least 4 times weaker. So you have a weaker string to pull you into a circle. It's like a car, right? Going around a turn. If you take a wider turn, it's less centripetal force, that you end up going slower in terms of the centripetal force. So the way to explain it is there's less gravitational pull, therefore it's less centripetal force, which is mv squared over r, right? The mass of the satellite hasn't changed, so therefore if it's less centripetal force, it's less velocity. It's kind of a wordy way to put it. So in other words, here's what's kind of cool. For every orbital distance you go from the Earth, there's a certain speed you have to go. So in outer space, there is no traffic cop, right? So how come satellites don't just crash and fall to Earth? It's because for every distance you go, you can only go a certain speed.